Which of the following represents 3-ethyl, 5-methyl, 2-hexanol? So let's take a look first at our parent chain. So that is the 2-hexanol. So the ol tells us that we have an alcohol as a functional group. So when you have a functional group, it modifies the parent name. The hex tells us 6 carbon atoms, and the ane tells us all carbon-carbon single bonds. And this 2 tells us the location of the alcohol. So if we are going to draw this, I'm going to start by drawing a 6 carbon atom chain of all single bonds. And I'm going to number that chain. And this tells me that on carbon 2, I have the alcohol. So that is a hydroxy group. So OH on carbon atom number 2. And notice I made sure that the bond was between the carbon and the oxygen. I wanted to make that very clear in my drawing because those are the two that are bound together. And now I want to put in the substituents. So 3-ethyl tells me that at carbon number 3, I have an ethyl group, which is a 2 carbon atom substituent. So 1, 2, and it doesn't matter if I bend this way or this way, it's going to be the same molecule. And then 5-methyl tells me that at carbon number 5, I have a methyl group, which is just a 1 carbon atom substituent. So we want to see if we can find what looks like this. So we only have 3 alcohols. In B, that alcohol is clearly the end of the chain, so that would be at carbon number 1. So let's check out A here. So 1, 2, 2, 3, and 3 doesn't have the ethyl group. So this is not the right compound. So let's check out D then. So 1, 2 all, 3 ethyl, 4, 5, 6, and we have a 5-methyl. And I could have just as easily numbered this bottom carbon as 6 because I still would have had a methyl group on carbon number 5. So D is the molecule we're looking for. So in this case, it actually did end up being drawn exactly as I drew it, but even if they looked slightly different with slightly different bond angles, if we had angled this a different way or counted down here, it would be the same molecule.